Mathematics, Chapter 4, Inverse Trigonometric Function. In exercise 4.1, we have saw y is equal to sin x and y is equal to sin inverse of x. We have drawn the diagram for y equal to sin x and both sin inverse of x also. In that we have saw principal domain and range for sin x and sin inverse of x curves. We have derived the few sums in exercise 4.1 using the three properties. Now we are entering in exercise 4.2 introduction part. As I gave the introduction for sin x and sin inverse of x, the same introduction I am going to give for cos x and cos inverse of x curve. It also have properties principal domain and range like the sin x curve and sin inverse of x curve. So we are going to derive the few sums in exercise 4.2. Now we will start with the diagram of y is equal to cos x. Y is equal to cos x. Cos x. The diagram for this y is equal to cos x will be, as we drawn on sin x, we need to put some changes in that curve and we are going to draw cos x. This will be y, this will be minus x, and this will be minus y. This is plus 1, this is minus 1. So curve starts from, sin x curve starts from here, nothing but origin, but cos x curve starts at 1. 1 it moves here and goes here and goes and moves as it is moves. The same here also in left hand side also goes and moves and goes. That's all. So this is 0, this is minus 1, this is plus 1. This is called Vs range. So we know this point is nothing but pi by 2. This point is nothing but pi by 2. This point is pi by 2 plus pi, which gives 3 pi by 2. This point is 3 pi by 2. 3 pi by 2 plus pi. This point is 5 pi by 2. So the same for negative. This is minus pi by 2. This is minus 3 pi by 2. This is minus 5 pi by 2. Point the first point as pi by 2. Pi by 2 plus pi, 3 pi by 2. 3 pi by 2 plus pi, 5 pi by 2. 5 pi by 2 plus pi is nothing but 7 pi by 2. Goes on, we don't need. So leave it as it is. Between the values of pi by 2 and 3 pi by 2, this point we called as pi. In between of value of 3 pi by 2, 5 pi by 2, this value we called as 2 pi. 5 pi by 2 and 7 pi by 2 we called as nothing but 3 pi. The same happens here. This is minus pi. This is minus 2 pi. This is minus 3 pi. You know the value. We have plotted the value. Even though we have plotted the value, we need to find the trueness of plotting the point here. So how we can find the trueness? Using the unit circle which we used in the previous introduction of exercise 4.1. X, y, x dash and y dash. If I am going to place point origin O, this point will be unit circle, radius is going to be 1, 1, 0. This point is 0, 1. This point is minus 1, 0. And this point is 0, minus 1. You know this is 0 degree and 2 pi. This is going to be pi by 2, pi by 2. This is going to be pi. This is 3 pi by 2. The value is nothing but 3 pi by 2. If it is anti-clockwise direction, starts here pi by 2, pi, 3 pi by 2 and once again 2 pi. Suppose it is in clockwise direction. This 3 pi by 2 moves this side, becomes minus pi by 2. Why minus pi by 2? Because of clockwise direction. This will become minus pi. You can able to understand, I think so. If it moves in clockwise direction, it happens like this. Minus pi by 2, minus pi. This become minus 3 pi by 2. This become minus 3 pi by 2. This become minus 2 pi. Therefore, moves in clockwise direction. So we can find the answer for this. So we know the curve y is equal to cos x. We know the curve y is equal to cos x. First I am going to apply the value for x is equal to 0. You know the cos is followed by angle. Cos inverse is followed by value. That one you should not forget throughout this chapter. Cos is followed by angle. So this is the angle. So x is equal to 0. If I follow x is equal to 0, you know The first one is cos, second one is sin. Therefore cos 0 is nothing but 1. Therefore y is equal to 1. Cos 0 value is 1. Suppose this one, cos 0 is 1, sin 0 is 0. After applying x is equal to 0, I am going to apply x is equal to pi by 2. X is equal to pi by 2. Y is equal to, where is pi by 2 angle present here? Cos pi by 2. Cos pi by 2. This angle, no. Angle cos pi by 2. This is cos, this is sin. Cos pi by 2 is 0. Cos pi by 2 is 0. I am going to apply, I can apply minus pi by 2 also. Since I apply pi by 2, I can apply minus pi by 2 also. Apply x is equal to minus pi by 2. So what will be y? X is equal to minus pi by 2. Cos of minus pi by 2. Once the minus pi by 2 comes, it moves in clockwise direction. So cos of minus pi by 2. Minus pi by 2 is present here. Therefore, this is answer. This is cos of minus pi by 2 is 0. Because first one is cos, second one is sin. Sin of minus pi by 2 is minus 1. Sin of minus pi by 2 is minus 1. So leave it as it is. After applying pi by 2, I am going to apply x is equal to pi. If x is equal to pi, where is pi is present? Pi is present. Cos pi value is minus 1. Y is equal to minus 1. Same if I go into x is equal to minus pi, what will be y? The minus pi is also same. Cos minus pi is also minus 1 only. Cos minus pi is also minus 1 only. So finally, I can apply any more values. For example, I can apply x is equal to 2 pi. I can try for x is equal to 2 pi. What is y value? Where is a 2 pi here? X is equal to 2 pi. This is cos 2 pi value is nothing but 1. So x comma y is the point. So this point will be 0 comma 1. So where is 0? This is 0. 0 comma 1 is 1. So this is the first point. 0 comma 1. So starting point is 0 comma 1. Next x comma y. Pi by 2 comma 0. This is in this axis y is 0. This is pi by 2 comma 0. See, we are joining these 2 points. Next pi comma minus 1. Pi is this one minus this one. This point is pi comma minus 1. Pi comma minus 1 is this point. So from here to here it joins here. Pi comma minus 1. You can able to this is pi, this is minus 1. Pi comma minus 1. Next minus pi by 2 comma 0. This is minus pi by 2 comma 0. Minus pi minus 1. This is minus pi. This is minus 1. This point is minus pi minus 1. 2 pi comma 1. Where is 2 pi? This is 2 pi. This is 1. 2 pi comma 1. If you want, you can use 3 pi by 2 also, no problem. The diagram. So I show the truthful of the diagram. Plotting the point also. Before plotting the point, I have drawn the diagram. Before plotting the point, I have drawn the diagram. But if you want, I can plot the point and draw the diagram. If you want, you can plot the point. Using this point, you can plot the diagram. So to show the truthfulness, to show the meaningfulness, so only I plot. After drawing the diagram, I show the point. I have plotted the point, and you can draw the graph using that point also. So no problem. So in that we have gone through the full cos x curve very thoroughly, as we done on sin x. So now the next video we will see domain, range and principal domain. So in this we can see the cos x, domain, range and principal domain. For first I will see domain. You know what is meant by domain. Next we will see range. Next we will see the principal domain. The principal domain is very important for this inverse trigonometric function. Domain. What is meant by domain? Domain is nothing but where this curve lies from x-axis. From where to where the curve lies at x-axis. You know the curve thrown lies on the x to x dash. The x to x dash nothing but this is a number line, fully real axis. So domain will be capital letter R or capital letter R. Otherwise we can write as minus infinity comma plus infinity in open interval. This is the first thing I can write. Range. The range will be, this is plus 1, this is minus 1. The range will be plus 1 comma minus 1. The range will be plus 1. First I will write domain. Domain is capital letter R or you can write as minus infinity comma plus infinity. Range is nothing but you need to use the closed interval minus 1 comma 1. Closed interval minus 1 comma 1. The principal domain is must. For principal domain we need to draw the diagram separately. We have 3 conditions for that. The first condition of principal domain should be a 1-to-1 or bijective, no problem. First by 1-to-1 or bijective, we see for 1-to-1 alone. For principal domain it should be a 1-to-1. The second condition is it should be covers the origin or near the origin. It should covers the origin or near the origin, or it touches the origin also, no problem. It should be near to the origin or covers the origin. The second one, it should not affect the range. We have three categories. We have three rules for principal domain. We have three rules for principal domain. The first rule is nothing but it should be 1 to 1. How we can be 1 to 1? Like we done on the y equals sin x, we should draw a line in the horizontal line test. You should cut at only 1 point. So it is called horizontal line test. It is called 1 to 1 function. It is called 1 to 1 function. It should cover the origin. It should cover the origin. The third one, it should not affect the range. For this diagram, I am going to take main thing this from starting from year to year. This is the part I am going to take 1, pi by 2 and pi. So I will draw this principal domain here. Nothing but I am going to take, this is the 1, it starts here and comes here. So this point is nothing but pi by 2 and this point is pi. From here only I will stop. This point is nothing but pi. So we will see. It is surely is going to be 1 to 1. Is called this x-axis nothing but 0. This is x-axis nothing but pi. It's surely going, this is x-axis, this is y-axis, x dash, y dash. What is the first point? It should be 1 to 1. Wherever we can draw a horizontal line, it cuts at only 1 point, so it is called 1 to 1. The second one, it is near to origin only. Yes, it is near to origin. Second one. Third one, it's not affecting the range. 1 to minus 1, it is minus 1. 1 to minus 1, it not affecting the range, so no problem. So the principal domain will be 0 to pi, that is closed interval of 0 comma pi, close 0 to pi. From x-axis only, domain means x-axis only, no. So you should not take 1 to pi, this is a wrong thing. 0 to pi, the x-axis only, we need to take nothing but 0 to pi. So using the principal domain only, we can able to find all the values using the properties also. So next we will move towards inverse function. That is, we can take y is equal to cos inverse of x. If cos inverse comes this way, becomes cos y. Therefore, cos y is equal to x. The same procedure we done in sin inverse of x also. So this is the x is equal to cos y. Now I need to draw the diagram for this. So the diagram for this nothing but this is going to be our x, y, x dash and y dash. This is origin O. This is origin O. Therefore, x is equal to cos y. We can take y is equal to cos inverse of x. So we can take x is equal to cos y. Using principal domain only, listen carefully. Using principal domain only, we are going to find 0 to pi. From up to 0 to pi only, we are going to draw cos inverse of x curve. So listen here. Cos, this cos is followed by angle. Therefore, y is angle. Y is angle. So we know the angle is nothing but 0 comma pi, principal domain. So we can take 0. If you want, we can take 1 nothing but pi by 2. Pi by 2. In between value 0 to pi, pi by 2. The last answer is pi. So what will be x value? So we don't need to worry for that. We don't need to worry for that. This is cos 0, no, cos 0 degree. So cos 0 degree, you will go and check here in unit circle. Cos 0, 0 degree. This is cos 0. Cos 0 is nothing but 1. This is 1. First one is cos, second one is sin, no. Cos 0 is nothing but 1. So you can put 1. Cos 0 is 1. Next, cos of pi by 2. Why is pi by 2? No, cos of pi by 2. What is cos pi by 2? See here, cos pi by 2. This is pi by 2. Cos pi by 2 is nothing but 0. So cos pi by 2 is 0. Cos pi by 2 is 0. Next, I am choose y. Cos pi. What is cos pi value? Cos pi value is nothing but first one is cos, second one is sin. No, cos pi value is minus 1. So write minus 1. Right, minus 1. So using this, I am going to draw the diagram. Listen here, 0, pi by 2 and pi. So this is our 0, this is our pi by 2 and this is our pi. 1 and minus 1. So this will be our 1 and this will be our minus 1. First point, y comma x is not a point. X comma y is the point. So how I can mark 1 comma 0? Where is 1 comma 0? This is 1 comma 0. The first point is 1 comma 0. Second point, 0 comma pi by 2. This is the point 0 comma pi by 2. 0 comma pi by 2. Pi comma minus 1. So this is pi, sorry, minus 0 comma pi by 2 minus 1 comma pi. This is minus 1. This is plus pi minus 1 comma pi. How I can draw the diagram? You can start here and you can end here. That's all. The diagram is that's all. This is y is equal to cos inverse of x curve. This is y equal to cos inverse of x curve. Otherwise you can say x is equal to cos y. Both are same only. You can say y is equal to cos inverse of x. Otherwise you can say x is equal to cos y. Both are same only. Both are same. So no problem. In this way, for this we have found, for this, that is cos x curve, we have found principal domain range. For this we will find principal domain range. Therefore principal domain, next we need to find range. The principal domain x-axis, no, minus 1 to 1, this is a principal domain. Minus 1 to 1 is a principal domain. Range, what will be range? The range is nothing but 0 to pi. Here see, this is pi, this is 0, nothing but the range is nothing but y-axis. Range is nothing but y-axis, no, 0 to pi. It not comes here. 0 to pi. The range is 0 to pi. That's all. So range is 0 to pi. So using this we can draw the diagram. Using this point you can draw the diagram of cos inverse of x and cos x also. So we have finished the diagram for cos x and cos inverse of x. Next we will see the properties. The properties is must. Properties. The first property is cos inverse of cos x. Second property is cos inverse of cos x. So both questions are same, but result is going to be different. X 2 pi minus x, both are same but different. You know, cos is followed by angle. So what is the angle we have? 0 comma pi is the angle. Value is minus 1 comma 1 is value. So if you are going to draw the diagram, 0 to pi, this is 0, this is pi, this is 0 to pi. Therefore x belongs to closed interval of 0 comma pi. X belongs to closed interval of 0 comma pi. This is pi. 0 comma pi. So the remaining after 0 to pi, what is the remaining here? Pi to 2 pi is the remaining. Just like a sign we need to take. Pi comma 2 pi. X belongs to pi comma 2 pi. This is the remaining. Pi comma 2 pi is the remaining. Pi comma 2 pi. In the side by side we also see property of sine. The first property, sine inverse of sine x is equal to x. Sine inverse of sine x is equal to pi minus x. This is x belongs to minus pi by 2 comma plus pi by 2. You can able to remember, I think so. Minus pi by 2 comma plus pi by 2. This is x belongs to, for minus pi by 2 comma pi by 2, this is the remaining, no, from year to year. This is plus pi by 2. In clockwise this is minus pi by 2 from year to year. Then what is the remaining for this answer? Pi by 2 comma, this you can say this anti-clockwise, pi by 2 comma 3 pi by 2, pi by 2 comma 3 pi by 2. The same thing here also, 0 to pi is principal domain and pi by 2 comma 2 pi is the remaining, pi comma 2 pi is the remaining. The same here also, minus pi by 2 comma pi by 2. This is minus pi by 2 if you are going to take clockwise. If you are going to take anti-clockwise, plus pi by 2, so minus pi by 2 comma pi by 2. This one is remaining. After this over, pi by 2 comma 3 pi by 2. You should not take minus pi by 2 because pi by 2 is from pi by 2 I am taking anti-clockwise. So pi by 2, 3 pi by 2 is in anti-clockwise. So third one, side by side we have seen this one also. Third property, cos inverse of minus x is nothing but pi minus cos inverse of x. This is very important formula. Cos inverse of minus x nothing but pi minus cos inverse of x. The same is done for sin inverse of minus x is nothing but minus sin inverse of x. The range is minus 1 comma 1. So here no problem here. This one we are going to derive as a third sum. As a third sum of fourth sum, I think so, in our exercise 4.2. Next we move towards the fourth property. This very important property, sin inverse of x plus cos inverse of x is equal to pi by 2, where sin is followed by value. So x belongs to minus 1 comma 1. X belongs to minus 1 comma 1. So listen students, for this one, the principal domain for sin x. The principal domain for sin x nothing but minus pi by 2 comma pi by 2. The principal domain for y equal to sin x. This is minus pi by 2 comma plus pi by 2. And the principal domain for y equal to cos x, 0 to pi. So you can easily, 0 to pi is for cos x, 0 to pi is for cos x, minus pi by 2 comma pi by 2 for sin x. You don't forget. Using diagram you can easily able to memorize this. Minus pi by 2 to pi, 0 to pi. 0 to pi. The range is going to be minus 1 comma 1 only. But one thing you don't need to memorize for sin inverse and cos inverse, because sin inverse is followed by value. That now sin is followed minus 1 comma 1. This one you can able to easily memorize. So if you are going to follow this, the sum will be very easy. Next we will do the exercise 4.2. Chapter 4, exercise 4.2. In this exercise we have gone through graphical of cos x and minus cos inverse of x, cos x and cos inverse of x. The first sum is exercise 4.2. The find the values of x. First subdivision, minus 6 pi less than or equal to x less than or equal to 6 pi and cos x is equal to 0. The question is nothing but in between values of minus 6 pi to 6 pi, for what values of x the cos will be 0, for what values of x the cos x will be, for what values of x it will be, cos will be 0. This is our main question for us. From minus 6 pi to plus 6 pi, minus 6 pi to plus 6 pi. So solution. We know the diagram which we drawn in exercise 5.1 also. So this will be x-axis, y-axis, x dash and y dash. A unit circle with origin O. This point is 1 comma 0. This point is 0 comma 1. This point is minus 1 comma 0 and this point is 0 comma minus 1. This will be 0 degree, 2 pi, 4 pi, goes on. The same, this will be pi by 2. I think you will remember the first sum in exercise 4.1, pi by 2, 5 pi by 2, each one increases by 4 and 9 pi by 2 goes on. This will be pi, 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. This is pi by 2. This will be 3 pi by 2, 3 pi by 2, 5 pi by 2. This will be 7 pi by 2. After 7 pi by 2, 9 pi by 2. After 9 pi by 2 is 11 pi by 2. Like this goes on. Okay, like this goes on. So this is we have studied in exercise 4.1 first sum itself. Not only first sum, in introduction part we have learned. Not only this, we have learned very clearly what we learned. X-axis in general, what will be? It will be n pi. X-axis positive side, nothing but 2n pi. Positive side is 2n pi. Throughout this x-axis is n pi. This one is 2n pi. X-axis negative, which is in odd. We know 2n plus 1 into pi. 2n plus 1 into pi. Next y-axis. Y-axis in general. Y-axis in general is nothing but, since the y-axis is nothing pi by 2 and it is odd, we can call as 2n plus 1 into pi by 2. In general is nothing but full y-axis. Full y-axis. So y-axis positive and y-axis positive and y-axis negative, both are present. Y-axis positive will increase by 4n plus 1 pi by 2. Y-axis negative 4 minus 1 pi by 2. These all we studied clearly in the first introduction part itself to draw the exercise 4.1 diagram also. In exercise 4.1 we have two subdivisions. To draw the diagram also we use this logic only. This logic is very easy. The first subdivision, minus 6 pi less than or equal to x less than or equal to 6 pi, when cos x will be 0. When it will be 0, see, cos x will be 0. The first one is cos, second one is sin. Cos, sin, cos, sin, cos, sin. Check it where first part is 0. This is 1. This is 0. This is minus 1. This is 0. So full of y-axis. This is 0. This is 0. So full of y-axis. The full of y-axis 2n plus 1 pi by 2. Full of y-axis nothing but 2n plus 1 pi by 2. So for minus 6 pi less than or equal to x less than or equal to 6 pi and cos x is equal to 0, x is equal to 2n plus 1 pi by 2. This n is nothing but belongs to z. But we need to take a suitable value for minus 6 pi to plus 6 pi. We need to take a suitable value for minus 6 pi to plus 6 pi. So if I going to take a value of n is equal to, if I going to take n is equal to 0, 2 into 0, 0 plus 1, 1 into pi by 2 is pi by 2, lies between minus 6 pi to plus pi, no problem. Next, if I going to take value of plus 1, 2 into 1, 2 into 1 is 2, 2 plus 1, 3 pi by 2, 3 pi by 2 is something 270, this also lies. If I going to take minus 1, 2 into minus 1, minus 2, this also lies. So plus or minus 1 also lies. If you are going to check it likely, it will move up to plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, up to minus 6 it moves. Plus 6 is not possible. If you want, we can check with plus 6. 2 6 are 12. 2 6 are for plus 6. 2 6 are 12. 12 plus 1 13. 13 pi by 2. This 13 pi by 2 is nothing but, we'll check here, 13 pi by 2. 13 into 90, because pi by 2 is 90, no. So 3 70, 2, 9, 10, 11, 1170. 6 by 6 into 180, no. You're going to check 8 6 are 40, carry 4, 6, 1080. This is 1170, this 1080. So this not lies. Minus 6 pi lies. Minus 6 pi lies. Other minus 6 pi lies. So this is the first subdivision. Next we move to a second subdivision. The second subdivision is minus 5 pi less than or equal to x less than or equal to 5 pi and cos x is equal to 1 and cos x is equal to 1. Where cos x is equal to 1 means we need to check. The first value should be 1. This is 1. This is 0. This is minus 1. This is plus 1. This is 1. So only positive x-axis. The positive x is nothing but 2n pi. The positive x is nothing but only 2n pi. So x is equal to 2n pi. I need to apply suitable values for n. So n is equal to 0. Because 5 pi to 5 plus minus 5 pi to plus pi, no, 0. 0 to pi is, if I going to take minus pi to plus 5 pi. Minus 5 pi to plus 5 pi. So n is equal to 0, it is possible. n equal to 1. 2 into 2 pi. 2 pi is possible. Minus 2 pi also possible. So plus or minus possible. I will take plus or minus 2. 2 2s are 4 plus 4 pi possible. Minus 4 pi is possible. If I going to take 3, 2 3s are 6. 6 pi is not possible. So this is the answer for this one. You need to check for each and everything. In spite of checking this, if you were well thorough, you can keep a remember of up to this sum is up to minus 6. This sum is plus 2. You can keep up to this. Second sum, x is 4.2. State the reason for cos inverse of minus pi by 6 is not equal to minus pi by 6. We need to say the reason. So what is the best reason we can say? We know the two properties. First two properties of cos inverse. Cos inverse of cos of x. Cos inverse of cos of x. Both the right and left hand side is same, but answer result will be different. Here x, here 2 pi minus x. When you can use this x value we can use when x belongs to 0 comma pi. This I can use when x belongs to pi comma 2 pi. So these are the two properties we can use. But here cos is followed by angle. So only we are putting the angle. So what we can do, if I am going to take this one, cos inverse of cos of minus pi by 6. If I am going to take cos inverse of cos of minus pi by 6, this if I am going to compare using property 1, this is property 1, property 2, using property 1 or 2, no problem. You can use any property 1 or 2, no problem, because this is also cos inverse of cos of x, this is of cos inverse of cos of x. This minus pi by 6 does not belong to 0 comma pi, and this minus pi by 6 does not belong to pi comma 2 pi. By using a property minus pi by 6 does not belongs to 0 comma pi, because this minus, no, this two both are positive values. In between 0 and pi, minus pi by 6 is not available, is not present. Not only this, in between pi to 2 pi, minus pi by 6 is not possible. Minus pi by 6 is not possible. So as minus pi by 6 not belongs to 0 comma pi, minus pi by 6 is not belongs to 0 comma pi, therefore cos inverse of minus pi by 6 is not equal to minus pi by 6. See here, cos inverse of x is equal to x. If x comes, ax, when this x belongs to 0 comma pi. Cos inverse of x is equal to x when x belongs to 0 comma pi. I can't use the second property because this is minus pi by 6. Straight answer minus pi by 6, minus pi by 6. I can use only property 1. I can use property 1 only. Why I can use property 2? Because 2 pi minus x. 2 pi minus 6 is not within our answer. So cos inverse of x is equal to s. Cos inverse of minus pi is equal to minus pi by 6. It's not equal. Yes, it's not equal. Why is not equal? This minus pi by 6 does not belongs to 0 comma pi. This is the main reason. So not only, if you want, you can do in another way also, but we can do in another way also. What is another way? Cos inverse of minus pi by 6. So cos inverse of, open the bracket, cos of minus theta. We know one formula. Cos of minus theta is equal to plus cos theta. So cos of pi by 6. So why cos of pi by 6? Cos of minus pi by 6. So cos of minus pi by 6 is equal to cos pi by 6. So cos inverse of pi by 6 is minus pi by 6. Now this pi by 6, see, we can use property 1. Cos inverse of pi by 6. This pi by 6, this pi by 6, this pi by 6 belongs to 0 comma pi. Plus pi by 6 belongs to 0 comma pi. Cos inverse of pi by 6 we can write as pi by 6. Why? This pi by 6 belongs to 0 comma pi. So this is equal to pi by 6 only. Cos inverse of minus pi by 6 will equal to pi by 6 only, not equal to minus pi by 6. So this answer is correct. Therefore cos inverse of minus pi by 6, answer is pi by 6. So this is not equal to, this is not equal. You can use from year to year. From year to year I finished answer. But this also you can write, no problem. Okay. Is cos inverse of minus x is equal to pi minus cos inverse of x true? He is asking whether it is true. Justify your answer. First you will take let y is equal to cos inverse of minus x. I have taken this is must, that y is equal to cos inverse of minus x. Let cos inverse come this side. So it becomes cos y. Cos inverse comes this way, becomes cos y. This becomes minus x. So after doing this, multiply by minus on both sides. If I go into multiply, either minus, already minus present, so minus into minus plus, plus into minus minus cos y. So this x is equal to minus cos y. I can add as cos of pi minus y. So listen here, minus cos y. I can add as cos of pi minus y. How we can write? Nothing but all silver teacup. All silver teacup. Using this we have studied. This is nothing but 90 degree. This is 180 degree. In this cos will be always negative. This is pi. Pi means it should not change. Pi means not change. Cos is always negative. Cos of 180 minus cos y is applicable here. Minus cos y is applicable here. Cos of 180 minus y. Cos of 180. Cos 180 is lies in the second quadrant. So only cos is negative. So we can write as minus cos y. In 11th standard you have studied detailing about all silver teacup. Cos of pi minus y. 180 minus y. 180 minus y lie in the second quadrant. So only cos is negative. So we will cos negative minus cos y. So minus cos y we can write as cos of pi minus y. Pi minus y. So the next step will be cos inverse. Let cos move this side once again, becomes cos inverse of x. Cos inverse of x is equal to pi minus y. Cos inverse of x into pi minus y. Let minus y moves this side, becomes plus y. Cos inverse of x moves this side, becomes pi minus cos inverse of x. Pi minus cos inverse of x. What is y? What is y we have seen? Y is nothing but cos inverse of minus x. Y is nothing but cos inverse of minus x is equal to pi minus cos inverse of x. Y is nothing but cos of minus x. This only we need to prove. Cos inverse of minus x equal to pi minus cos of x. So yes, it is true. Yes, the final answer, it is true. This union says it is true. So only one thing you need to learn, that is this one. Cos of pi minus y is nothing but cos y. If you want, you can write cos of 180 minus theta is nothing but minus cos theta. In present of theta, we written y. 180 minus theta lies in second quadrant. In second quadrant, cos is negative. So we put cos 180. The cos will remain as it is. So cos theta. Here y. So we have put y. That's all. So this statement is true. This is nothing but very, very important sum. For the sum, very, very easy sum. Find the principal value of cos inverse of 1 by 2. We know the table which we study in the lower standard, 9th standard, theta 0 degree, after 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, cos theta. Cos 0 is nothing but 1. Cos 30 is nothing but square root of 3 by 2. Cos 45. What is cos 45 value? The cos 45 value is 1 by root 2. Cos 60, 1 by 2. Cos 90, 0. We need to find the principal value of cos inverse of 1 by 2. Cos inverse of 1 by 2. Listen very, very carefully. It's very, very easy. Where 1 by 2 is present here? Cos 60 is 1 by 2. We know always the inverse is followed by value. Inverse is followed by value. Inverse. Cos is followed by angle. Cos inverse is followed by value. So cos inverse is followed by value. Cos 60. This is cos. Angle. We have got 1 by 2. When cos inverse is followed by value, we get angle. What is angle? Angle is nothing but 60. What is 60? 60 we can write in radian as pi by 3. That's all. Very simply we finish the sum. This pi by 3 belongs to cos 0 comma pi. Because it is angle. Pi by 3 is an angle. Belongs to 0. Very easy. Only one line answer. Only one line answer. Here cos is followed by angle. So cos 60 is 1 by 2. Now cos inverse is followed by value. So we get angle. What is 60? This is pi by 3. This pi by 3 is nothing belongs to 0 comma pi. So this is our required answer. Fifth sum. First subdivision. Find the value. First subdivision 2 cos inverse of 1 by 2 plus sin inverse of 1 by 2. For this first we need to know the table which we study in the lower classes. Theta 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. This is an angle. We will give in pi by 30 is nothing but pi by 6. This is pi by 4. 60 pi by 3. This is pi by 2. So first sin theta. Next we will show cos theta. Sin 0 is 0. Sin 30 or pi by 6, which is 1 by 2. Next 1 by root 2. Next root 3 by 2. Next 1. 1 root 3 by 2. 1 by root 2. 1 by 2 and 0. See 2, write 2 as it is. Cos inverse is followed by value. Where is cos? Cos where is value? 1 by 2 value. Cos inverse of 1 by 2 is nothing but pi by 3. 2 into pi by 3. How easy the sum is. Sin is followed by value. Sin inverse. Sin inverse of 1 by 2. Nothing but pi by 6. 2 pi by 3. 2 pi by 3 plus pi by 6. So we can take easily LCM. So 2 pi by 3 plus pi by 6. LCM is 6. So multiply with 2. 2 2s are 4 pi. 4 pi. This is pi. Whole divided by 6. Nothing but 5 pi by 6. 5 pi by 6 is the first subdivision. Cos inverse of 1 by 2 plus sin inverse of minus 1 is the second subdivision of the fifth sum. So first we will rearrange properly. Cos inverse of 1 by 2 plus this one we have a property. What is the property? Sin inverse of minus x is nothing but minus sin x minus sin inverse of x. Sin inverse of minus x is nothing but minus sin inverse of x. sign is followed by value. So x belongs to minus 1 comma 1. So you see, this is minus, this is minus. What is x value? X value is 1. 1 is present here, no? 1 is present, so no problem. So we can write, we can take this plus and put minus sine inverse of 1, because plus into minus, minus. So because sine inverse of minus x, we can write as minus sine inverse of x. So it's happened. So cos inverse of 1 by 2. Cos is followed by value, sine is followed by value. First in cos we need to find 1 by 2 value. In cos we find the 1 by 2 value. Cos 1 by 2 value is pi by 3. Pi by 3 minus sine inverse of 1. In sine is followed by value. 1 is nothing but pi by 2. Pi by 2 minus pi by 2. Now cross multiply. 2 into pi is 2 pi. 3 into pi is 3 pi. Divide by 3 2s are 6. So 2 pi minus 3 pi is nothing but minus pi by 6. Answer is minus pi by 6. Very easy sum. Next, third subdivision. Third subdivision, cos inverse of cos pi by 7, cos pi by 17 minus sin pi by 7, sin pi by 17. For this we need to learn one formula. The formula is nothing but cos of a plus b is nothing but cos a cos b minus sin a sin b minus sin a sin b. This is the formula we need to apply. So write this already. Cos pi by 7 cos pi by 17 minus sin pi by 7 sin pi by 7 and sin pi by 17. Here a is pi by 7, b is pi by 17. So we can write cos as pi by 7 plus pi by 17. So cos inverse of cos pi by 7 plus pi by 17. Close. This one we can cross multiply. 17 into pi cos inverse of cos 17 into pi 17 pi plus 7 into pi 7 pi 7 into 17 is 119. Closing. So it's nothing but cos inverse of, open the bracket, cos of 17 plus 7 is 24 pi. 24 pi divided by 119. So cos inverse of cos, we have two properties. What is the first property? Cos inverse of cos of x is equal to x. Cos inverse of cos of x is equal to 2 pi minus x. Here x belongs to 0 comma pi. Here x belongs to pi comma 2 pi. In that 24 pi by 19. 24 pi by 190. This one belongs to within this interval, in the 0 to pi or pi by 2 pi. Listen carefully. This 0 and pi we can write as this 0 and pi. Listen very very carefully. 0 can be written as 0 pi, 0 into pi. This pi I can write as 1 pi. Nothing but 0 to 0 pi to 1 pi. 0 pi to 1 pi. We can write in simplest way. So this 24 pi by you can divide 24 into 180 divided by 190, which gives 0.201. So since it is 1 pi, here it located 0.2. 1 pi before 0 pi to 1 pi in between value is nothing but 0.2. So we can write using the property 1, this property. Cos inverse of cos we can write as 24 pi divided by 119, because this is belongs to, which one belongs to? 24 pi. Therefore 24 pi by 119 belongs to 0 comma pi. Suppose this one belongs to, in this value we need to write 22 pi minus x. 2 pi minus 24 pi by 119. But this 24 pi divided by 119, which lies surely going to lie. Surely it going to lie between 0 to pi, nothing but 0.2 value. 24 by pi divided by 24 pi divided by 119 is nothing but 0.2. 0.2 lies between 0 to pi, because it is 0 means 0 pi. 1 means you can write nothing, no number, no. We can write 1 pi, no. 1 pi, so 0.2 lies here. So this is our required answer. Sixth sum, very very important sum. the same model we saw in exercise 4.1, find the domain. So here also we are going to see the same model, find the domain. First solution, f of x is equal to sin inverse of modulus of pi minus 2 divided by 3 plus cos inverse of 1 minus modulus of x divided by 4. Very, very important sum. In this, we are going to take this value alone, this value, because we are going to solve this expression unless we are going to get the value of x. So solution, we are going to take this value alone. How? Modulus of pi, modulus of x minus 2 divided by 3. Okay, we know sin inverse is followed by value. What is the value? Minus 1 to 1. So minus 1, you need to put plus 1. This is for first one. This is a first expression. Then we go for second expression, nothing but cos inverse. For this 1 minus modulus of x divided by 4, the same value minus 1 to plus 1. We need to find up to we get the value of x. So we can move 3 here. So minus 3 less than or equal to modulus of x minus 2. We can move plus 3 here also. In other words, we need to multiply by 3. To remove this 3, we need to multiply 3. This minus 2 goes this side, becomes plus 2. This minus 2 goes this side, becomes plus 2. So 3. Only x remains. So less than or equal to minus 3. How? Minus 3, minus 2 come this side, become plus 2. Plus 3, minus 1 become plus 2. Minus 3 plus 2 is nothing but minus 3 plus 2 is minus 1, less than or equal to modulus of x less than or equal to 5. So if you are going to check, minus 1 is less than 5. 5 is greater and compared to minus 1. Minus 1 is less than 5. So we can express this one also. 4 moves here. So minus 4 less than or equal to 1 minus modulus of x less than or equal to 4 moves this side also 4. This 4 moves this side, 4 moves there. Next plus 1. Plus 1 moves this side, becomes minus 1. This plus 1 moves there, become minus 1. 4 minus 1. So remaining is minus modulus of x. Minus 4 minus 1 is minus 5 less than or equal to minus of modulus of less than or equal to 3. Check it carefully whether minus 5 is less than or equal to 3. Yes, but still minus is present. Still minus. I need to remove the minus. If I need to remove the minus, I need this minus become plus. This minus become plus. This plus become minus. But symbol will change. This symbol will be moved as it is. Symbol will change. Why symbol is changing? Because this minus become plus. This minus become plus. This plus become minus. Suppose if you want, you can check one by using one on. Suppose 5 is less than 3. No, sorry, minus 5 is less than 3. Minus 5 is less than 3. Yes. Suppose change the symbol, change the sign. This plus 5 minus 3. Whether this is correct? 5 is less than minus 3. No, this is not correct. This is not a proper. 5 is, even though we have changed the sign, we are not changed the inequality. 5 is less than minus 3. No, this is not wrong. So while we are changing the sign, this minus become plus 5, this plus become minus 3, we need to change the inequality also. 5 is greater than minus 3. See, in 5, which is biggest one? 5. So it is open this side. So this is, so what? If you are going to multiply, if you are going to change the sign, minus become plus, plus become minus, you need to change the inequality also. The same procedure. Minus become plus, plus become minus, minus become plus. The inequality also we are going to change it. So, but we can do in another way. How? This minus 3, we can minus 3 is less than or equal to modulus of x less than or equal to 5. So this minus 3 I can brought here. 5 is greater. Here also 5 is greater. Minus 3 is more than minus 3 but less than 5. Minus 3 is less than when compared to 5. So this is still we are not finished the diagram. So we have got one value here, we have got another value here. So one of the formula we need to write. Formula. What is the formula? This formula is must. You need to know this formula. Without this formula, we can't able to do sum. This is nothing but a is less than or equal to modulus of x less than or equal to b. This is given out example sum in first exercise. A is less than or equal to x less than or equal to b. We need to write x belongs to change this sign plus b, change this sign minus b, change the sign comma minus a union. Now write this a and b. You can able to understand what I am saying. Listen carefully. Change the sign. Minus b minus a union a comma b. Yes sir. The same procedure follow for this one also. A less than or equal to x less than or equal to b. The same. Therefore x belongs to, change the sign, minus 5, change the sign, minus become plus 1 union a comma b minus 1 comma 5 minus 1 comma 5. The same we can do here also. X belongs to, change the sign, minus 5, change the sign, plus 3 union, now minus 3 comma 5, right as it is. So in this we have written. Now I am going to draw one diagram. Minus 5 1 minus 1 minus 5 1 minus 1 5. What is present here? Minus 5 is present, plus 5 is present, minus 1 is present, 1 is present. So first minus 5 to 1, minus 5 to 1 is this one, minus 5 to 1, this is minus 5 to 1. Next minus 1 to 5, minus 1 to 5 means from year to year. So union means we know all, we need to write all. So minus 5 to 1, minus 1 to 5, from year to year, we need to mingle, that is union. Simply we can write minus 5 to 5. In spite of writing minus 5 to 1 and minus 1 to 5, we can write a full value. This full value no, minus 5 to 1, minus 1 to 5, we can take the full value itself. The same we can see here also. See here, this is minus 5 plus 5, minus 5 to plus 5, plus 3 minus 3. So put minus 3 and plus 3. Minus 5 to 3 from year to year. Minus 3 to 5 from year to year. In spite of writing half of value, see this up to year one value, union from year to year another value. Union means all. So in spite of writing half of value, we can write full value itself. That is minus 5 to 5. Here also minus 5 to 5. For equation 1, equation 2, by combining 1 and 2. By combining 1 and 2, this answer is minus 5 to 5 only. This answer is minus 5 to 5 only. So we can write minus 5 less than or equal to x less than or equal to 5. So this is the domain. Second subdivision of the sixth sum, g of x is equal to sin inverse of x plus cos inverse of x. In spite of x, another value is present. In spite of x, another value is present. We will try to solve this sum. But there is no value in spite. There is x itself present. X is present means straight value is present. You know sin inverse of x curve. The sin inverse of x, sin is followed by value minus 1 to 1. Cos inverse of x value. Cos is followed by value minus 1 to 1. Therefore, the domain for sin inverse of x is minus 1 to 1 and cos inverse of x is minus 1 to 1. For both the things, the domain is same, minus 1 to 1, because sin is followed by value, cos is followed by value. Therefore, finally we can write the domain of g of x. The domain of g of x is minus 1 to 1. G of x is minus 1 to 1. You know, you also draw the diagram, no? The x value contains minus 1 to 1 for sin inverse of x curve. The same for cos inverse of x also. The x value contains minus 1 to plus 1. What is the domain? In x where the curve lies, minus 1 to 1. In x where the curve minus 1 to 1. For sin, if you have any problem, go and see the sin inverse of x curve. The x contains minus 1 to 1. For cos inverse also, x contains minus 1 to 1. Very important sum. For what values of x? What values we need to apply for x? So the inequality pi by 2 less than cos inverse of 3x minus 1 less than pi. So see here, first I write the inequality. Pi by 2 less than cos inverse of 3x minus 1 less than pi. We are going to see pi by 2 is less when compared to pi. We are going to see this. Pi by 2 is only 90. Pi is 180. So pi is bigger when compared to pi by 2. Okay. So I am going to take cos on both sides. Take cos on both sides. Therefore, if you going to take cos and see cos pi by 2, I will write inequality afterwards. Cos inverse of 3x minus 1. I will write inequality afterwards. Cos pi. You can able to listen what I am saying. Listen very carefully. If I going to take cos pi by 2, I taken cos pi by 2, cos inverse of 3x minus 1 cos pi. So listen, what is cos pi by t value? You know, cos pi by t value is nothing but, what is cos pi by t value? 0. This cos and cos inverse can be removed. Cos and cos inverse we can cancel and remove. Nothing but 3x minus 1. 3x minus 1. Cos pi value is minus 1. Listen very carefully. Suppose I am not having any pencil. Suppose we are going to put symbol like this. Symbol I am putting very small. Symbol like this. The same symbol. See, 0 is less than minus 1. 0 is less than, whether 0 is bigger or minus 1 bigger means 0 is bigger when compared to minus 1. Because after 0 only minus 1 comes. 0 is bigger. 0 or 1 is bigger, 1 is bigger. 0 or minus 1 is bigger, 0 is bigger. But if I am going to put symbol, see the symbol is, if I am going to put symbol like that, problem rises here. 0 is less than minus 1. It's wrong, no. I have told first itself. Pi by 2 is greater than pi. Pi by 2 is less than pi. Pi by 2. 90 is less than 180. Yes, 90 is less than 180. 90 is less than compared to 180. After taking the cos, the problem rises here. After taking the cos, the problem rises. What is the problem rises here? The problem rises here nothing but cos pi by 2 answer is 0. Cos pi by 2 answer is 0. Cos pi yes answer is minus 1. Now minus 1 is smaller when compared to 0. 0 is bigger when compared to minus 0 is bigger when compared to minus 1. So if I going to put this inequality, the sum is going to be totally wrong. So we need to change the, after taking the cos, we need to change the inequality. This is the main thing. You can able to understand. Take cos on both sides, change inequality also. Most of the students will not change, so sum will be wrong. After taking cos, change the inequality also. This is the main problem. Why, sir? I can tell you some reason. This pi by 2 and pi is in second quadrant. Pi by 2, pi is second quadrant. In second quadrant, cos is negative. Cos is negative. Once if I going to take a cos, negative arises. If negative arises, I need to change the symbol. In previous sum also we saw. If once a negative comes, we need to change the inequality. We need to change the negative comes. This minus become plus, plus become minus. We need to change the symbol. We need to change this inequality. Less is changed to greater. The same procedure you will follow. Once the cos arises here, the negative comes. We not put in the negative. But we need to take. It is when negative comes. As the negative comes, we need to change the symbol. Cos means this cos lies in second quadrant. Since cos is negative, this negative arises. So we are not putting the negative, but we are changing the symbol. You can take this way. Other way, cos pi by 2 is 0, cos pi is minus 1, cos 0 is lesser when compared to 0 is greater when compared to minus 1. So we change inequality. Now we have changed some more inequality. How? First put minus 1, change the symbol. 3x minus 1 less than 0. So minus 1 is less than 0. Okay, this minus 1 comes this side, becomes plus side. So only 3x. This minus 1 comes this side, becomes plus 1. Okay, minus 1 plus 1 0. 0 less than 3x less than 1. So this 3 comes down. 0 by 3 less than x less than 1 by 3, which implies 0 by 3 is 0 less than x less than 1 by 3. So this is the answer. 0 less than x less than 1 by 3, or you can write x belongs to 0 comma 1 by 3. Within this we can finish this sum. Very very important step this one, by changing the inequality. 8th sum, exercise 4.2, the last sum in this exercise. So for this I am going to use two properties. This is a well known property for you. First property is cos inverse of cos x. Cos inverse of cos x is equal to x. Next, cos inverse of cos x is equal to 2 pi minus x. For both things, x belongs to 0 comma pi. This one x belongs to pi comma 2 pi. So this is okay. Next we are going to choose another formula. What is another formula? Cos inverse of x plus sine inverse of x is equal to pi by 2 when this x belongs, cos is followed by value, x belongs to minus 1 comma 1. These three properties we are going to use in this sum. So this 4 by 5 is less than 1. 4 by 5 is less than 1. So minus 1 to 1, this 4 by 5 will be present, nothing but 0.8. Nothing but 0.8. This point is minus 1 to 1. Minus 1 to 1. So cos inverse of x, sin of x, nothing but pi by 2. How I can write cos of, if x comes, x 4 by 5, 10. Cos inverse of whatever comes, no problem. This 4 by 5 is less than 1. 4 by less than 1 is minus 1 to 1 is the range. Minus 1 to 1 is the range. What is 4 by 5? 4 by 5 is nothing but we need to check this point. Since 4 by 5, we can write 4 by 5 belongs to minus 1 comma 1. So we can apply the formula. What is the formula? Cos inverse of x, sin inverse of x is equal to pi by 2. Cos inverse of 4 by 5, sin inverse of 4 by 5 is nothing but pi by 2. What is cos pi by 2 answer? 0. Simply we can finish. Whatever answer. Next is second subdivision. What is second subdivision? Cos inverse of cos 4 pi by 3. Next, plus cos inverse of cos of 5 pi by 4. Close the bracket. Now we need to apply some. See here, this 4 pi by 3 is greater than pi by 3, greater than pi. I can't use this property. I am going to use this property because pi comma 2 pi, 4 pi by 3, 4 into 180 by 3 is greater than pi, 5 pi by 4 greater than pi. So since this 4 pi by 3 is belongs to pi comma 2 pi and 5 pi by 4 is belongs to pi comma 2 pi, use property number 2. How? Cos inverse of cos x is nothing but 2 pi minus x. How I can write 2 pi minus, what is x here? 4 pi by 3 plus the same here 2 pi, what is x here? 5 pi by 4. If you want, you can write the condition. What is the condition? Whatever you written, right here the same. 4 pi by 3 belongs to pi comma 2 pi, 5 pi by 4 becomes pi comma 2 pi. If you want, you can check. If you want, you can check. 4 into 180. What is pi by 3? Pi by 3 is 60. 60 into 4, 240. 240 lies above pi but below 360. So it lies here only. 5 pi by 4, 5 into 45. This also lies above pi but below 360. So only. So 2 pi plus 2 pi which gives 4 pi minus 2 pi minus 2 pi which gives 4 pi. Next 4 pi by 3 minus 5 pi by 4. Throughout LCM is 12. LCM is 12. So LCM is 12 means whole divided by 12. If I am going to get 12, what I want to do? I need to multiply with 3. 4 3s are 12 pi. I need to multiply with this 4. 4 4s are 16. I need to multiply. I need to get 4 no 3. 5 3s are 15. So 12 pi minus 16 minus 15. So 15 minus 16 is nothing but 12 pi. Sorry, this one is I need to multiply 12. No, 1 into 12. Sorry, 12. 48. Sorry, student, this is 48. This 4 pi no. I should multiply 12. 12 and 12. So only denominator is 12. 12. 2 4s are 8. 1 into 4, 48 pi. 48 pi. 48 pi minus 16 minus 15 pi is nothing but minus 31 pi divided by 12. So 48 minus 1. 8 minus 1. You can take. 8 minus 1 is 7. 4 minus 3 is 1. Still pi remains. 17 pi divided by 12. This is very easy to do in this method. Using the property 2, you can do this sum in this method. If you are going to do any other method, it is very tough. Within this, we are finishing this exercise.